A tank is filled with water to a height of 12.5 centimeters. The apparent depth of the needle lying at the bottom of the tank is measured by microscope to be 9.4 centimeter. What is the refractive index of water? That has been asked. So if water is replaced by a liquid of refractive index 1.63 up to the same height, by what distance would the microscope have to be moved to the focus on the needle again? So we can roughly draw the diagram that this is a tank which is filled with water to a height of 12.5 centimeter, and a needle is placed at the bottom of the tank. This is AB. Now due to this water, somebody seeing through microscope, the needle appears to be at, the apparent depth is 9.4 centimeter. The apparent depth means which is not real depth, artificial depth which is been seen by microscope. So according to the formula, the refractive index of water would be the actual depth divided by the real depth, apparent depth. This is the actual divided by apparent, and when you will divide this, you will get 1.33 as the refractive index of the water. Now the second part of the question is, if the water is replaced by a liquid of refracting index 1.63 up to the same height, then by what distance microscope have to be moved to focus on the needle? So now this is unknown liquid refractive index. So actual depth divided by apparent depth, we don't know about the new apparent depth. So apparent depth will be 12.5 divided by 1.63. So I'll take out calculator. And we'll see that how much is this value. 12.5 divided by 1.63 is equal to 7.67. 7.67. So by virtue of this liquid refractive index, the apparent depth is now the AB is appearing to be at again upwards. So this apparent height has become less, 7.67 centimeter. So our microscope through which we are looking at this needle has to move backwards. By what distance? 9.4 minus 7.67. So 9.4 how much it would be? 9.4 minus 7.67 by a distance of 1.73 centimeter. The microscope has to be moved backwards so that it has a sharper image of this needle.